All right, welcome to day 5 of Unit 9. This is our last day of this unit. And what we learned yesterday was a formula for exponential growth or decay. And in our formula, we had a plus or a minus sign depending on whether or not it was growth or a minus sign if it was decay. And we specifically focused on the rate at which things are growing by. So usually rate represents a percent, whether it's increasing by a certain percentage over time or decreasing over a certain percentage over time. Today, we're going to throw a new little twist in there, and we're going to be calling it compounded interest. So now today what you're going to notice is this new word compound or compounded in the problem itself when we're coming up with our variables. All the other letters should look familiar. A, P, R, and T are all exactly the same, and they all represent the same thing. But compounded interest is interest that's earned on the principal amount, so your initial amount, and on any previously earned interest. So, for example, when you put money in a bank, you get interest on that initial deposit. But now that you gained interest on that, you now are going to get interest on the interest that you've already earned from that initial deposit. And then you get interest on the interest on the interest. So it keeps compounding and growing over time. So that's why we call it compounded interest. So A is still going to represent your final amount that you have in your bank account. So remember, that's the after amount. P is still going to represent the initial that you deposit in the bank or the initial population or whatever. Some people use the word principal amount. And sometimes my students call it the pre-amount. R is still the rate as a decimal. Everything there is the same, and T is still time in years. Here's where the change comes in. N is going to represent how many compounds fit in a year. So if I say it's only compounded annually, that's 1 time per year. But if it's semi-annually, that's happening 2 times per year. Quarterly, we'll think there's 4 quarters in a dollar, so that's 4 times per year. Okay, so we left off with quarterly is 4, so think like 4 quarters in a dollar. Monthly, how many months are there in a year? So that one's going to be 12. Daily is how many days, not including leap years, so 365. Weekly, so that one's usually tough for kids because they're not familiar with how many weeks are in a year. There are 52 weeks in a year. Ignore my dog drinking in this one as well. So if it's bi-weekly, when you get to be an adult, most adults are paid bi-weekly, which means once every 2 weeks. So basically, if there's 52 weeks in a year, bi-weekly would be 26. So half of that. All right, so if we know our compound numbers, that's the only new thing in our formula. So let's take a look at number 1. Maria's parents invested $14,000 at 6% per year compounded monthly. How much money will be in the account after 10 years, round to the nearest cent? So let's think about what we know. She invested $14,000. That is her initial investment. So that's our P value. 6% is our R, so R is 0.06, just like yesterday. Compounded monthly means that N is 12. How much money will be in the account means I don't know A after 10 years T. So those are my variables, and the letter that I'm going to be solving for here is A. So let's fill it into our formula. I tried to keep it on the screen, but you should have it on your page there. A equals 14,000, that's our initial amount, 1 plus the rate, divided by the number of compounds, raised to the N, so 12 times per year for 10 years. You can literally type that entire thing all in one fell swoop. Or if that's how you say the saying, who knows. All right, so 14,000. 1 plus, I do alpha, so green, y equals enter, so that I can type that in exactly as I see it on my page, divided by 12, parenthesis, raised to the 12 times 10, hit enter, and if it says round to the nearest cent, we are talking about pennies, which is 2 decimal places in. So we are going to increase our investment up to $25,471.55. So not too shabby. Number 2, if I borrow $20,000, so that's how much I'm going to be borrowing as my loan. At 4%, there's my rate. Compounded semi-annually, so that is 2 times per year. To buy a new car, what will my total payments be? So how much will I end up paying back? We're going to keep going even though that noise is happening again. After a 5-year loan. So let's first figure out that answer, because this is actually a 2-part question. So we have $20,000. 1 plus R divided by the number of compounds raised to the n times t. So it's happening twice a year for 5 years. So it's going to be 10 total payments. So I would type that in my calculator just like I typed the last one all in. Round to the nearest cent again because we're talking about money. And I actually will end up paying back $24,379.89. So when you take out a loan from a bank or something like that, you don't just pay back what you wanted in the loan. That's how the banks make money. So there's always interest on top of the loan that you take, and that extra money is what the bank gets to keep. So part B of this question says, how much interest did you end up paying? So even though you asked for $20,000, you ended up paying them back $24,000. So how much did you pay them back in interest? So you take your answer you just got, you subtract the amount that you initially asked for, and that difference is how much you paid in interest to the bank or wherever you decided to get your money from. So that is part B of the question. So your initial was that, and then that's how much you paid in interest. All right, only a couple more. Number 3, Theo invested $6,500 at 4.5% compounded quarterly. What will his investment be worth in 4 years, and how much interest did he gain? So in this case, this is an investment. So he puts $6,500 into an investment at a rate of 0.045. So I converted my percent to a decimal. Compounded quarterly. So quarterly, again, think quarters. Quarters there's 4 in a dollar, so quarterly would be 4 times a year. And after 4 years, so time is 4. So let's first figure out how much he makes after those 4 years. So our initial investment is $65,000. We have our rate divided by how many compounds there are, and then it's happening 4 times a year for 4 years. So a total of 16 times would be our exponent there. So again, I would take out my calculator, type that all in, hit enter. We're talking about money, so round to the nearest penny, so $7,774.10. That is how much I now have. But remember, I invested $6,500. So by just literally putting my money and letting it sit there for 4 years, how much did I gain on that initial investment? So how much interest did I earn? So $7,774.10. Subtract my initial investment, and I am earning $1,274.10 just by letting it sit there for 4 years. So that is how much interest I gained. Not too bad for literally just putting money and letting it sit. All right, Jim's investment of $4,500 has been losing value. So that's important, losing value. So that's decaying. All right, so if our initial investment was $4,500 and has been losing value at a rate of 2.5% each year, what will his investment be worth in 5 years? What I noticed while reading this statement, I did not hear them ever say the word compounded. If you never hear them mention the word compounded, you do not have to use the compounded formula, which is the one we learned today. If they never say compounded, you actually can go back to this formula. So I don't have to figure out what n is in this problem. There isn't an n. We initially invested $4,500. It is losing value at a rate of 0.025. Time is 5 years later, and I just want to know how much money I'm going to have. Well, actually, how much money I lost. All right, so if I plug 4,500, 1 minus the rate to the 5 years later, and type that all in my calculator all in once. Unfortunately, my investment was losing money, and so now my investment is only worth that much. Last one. Number 5, write a function that represents the balance of an account if a $2,000 deposit earns, so adding 5%, compounded weekly. So, okay, compounded, there's that fancy word, so we know we have to use our new formula, so 52. So write a function. That's part A. Write a function. So A equals P1 plus R divided by N to the N times T. That is a function because it is in terms of a variable. I still have T in the function. That's part A. Part B says now that you have this equation, determine your balance after 5 years. So now I'm going to take that equation and I'm going to substitute 5 where T is because it's 52 times for 5 years. I type that all in my calculator all at once, and my investment increases up to $2,567.74. All right, that takes us to the end of our exponentials unit from home. So look for a review packet coming out to you shortly in the next few days. Bye.